In this new soap opera called Graphs and Equations, we have Mr. Langston introducing this topic to his pre-calculus class. Mr. Langston, please go.
Well, thank you. Now, graphs and equations. First thing I've got for you is determining solution points, which basically is asking you the question of, does this point lie on the graph of this equation? To solve this, all you have to do, very simple thing, say it with me, you guys. I say it all the time. Plug it in from S.C. Johnson, a family company. So what I expect you guys to do is, we got the equation of y equals 10x minus 7. I'm going to write it right over here. Y equals 10x minus 7. And all you have to do is take 213 to find out whether it lies on the graph. Take 213 and plug it in. So I'm going to call this my x. I'm going to call this my y, just to remind myself. And now I'm going to plug it in. I got 13. Oops, I didn't mean to make that line there. Get rid of that line. Equals 10 times 2 minus 7. 10 times 2, that's 20 minus 7. Is it equal to 13? Is it? 20 minus 7? 13. It is equal to 13. I've cleansed the demon. Praise the Lord. So, yeah, that means that the point 213 is on the graph of y equals 10x minus 7. Now, the next question right here is -1, -3 on the graph. So, again, I'm going to label it x and y. I'm going to get my equation, y equals 10x minus 7. And I'm going to do exactly the same thing and plug it in. So I've got my x is -1. So it's 10 times -1. I'll put that in parentheses. Minus 7. And does that equal to -3? So let's check. 10 times -1. -10. Minus 7. That's a weird 7. Let's get that fixed. Is that equal to -3? -10 minus 7 is -17. So, is it equal? Heck no. It's not equal. What's the matter with you? So, what does that mean? It means the point -1, -3 is not on the graph of the equation y equals, oops, made a mistake. So sorry. Y equals 10x minus 7. So let's go to the next one. Sketching the graph of the equation. For this one, you guys should know you're going to find the y-intercept. You're going to use the slope, and you're going to plot. So for instance, I've got y equals -1/2 x plus 2. I'm going to find right here is my y-intercept, positive 2. Boom! Positive 2 on the y. If it was -2, I'd be down here putting -2. But it's not. It's positive 2. Pay attention. So now I got my slope. My slope is -1/2. Now this negative is outside. It's outside the fraction. What I've got to do is I've got to bring it into the fraction. Now, one thing I need to tell you, because I see students make this mistake, is they'll sit there and they'll bring the negative into both sides of the fraction, top and bottom. They'll write it like this: -1 over -2. Okay, now I'm going to find my rising round. No! How many negatives you got there? How many? You got one. One negative. So guess what? That negative is either going to go to the top, it's going to go to the bottom. That negative didn't have no babies. So what you need to do is put it somewhere, either top or bottom, and only in the one spot. What I end up doing is I always, and this is just me, I always put my negative to the top. So what I'm talking about is that's going to be equal to negative 1 over 2. Negative goes in one spot only. Now the negative 1, remember, everybody can remember rise over run. So that negative, that means I'm going to go down because my rise is negative, which means going down. And my run, now it's a positive 2. So positive 2, this is my positive run, this is my negative run. This is my positive rise, this is my negative rise. So that positive 2 means I go to the right. So I'm going to go down 1, right 2. So let's just do it. Down 1, right 2. Down 1, right 2. So that is going to be my line. Now I messed up over here a little bit. It should actually go through right here. Okay? Sorry. Forgive me. So next slide. You're going to sketch the graph of y equals x squared minus 1. Now, I can show you not phase shifts, but slides and everything. But the reality is that's a whole section by itself. You got a quadratic or something, just plot the points, man. Just plot the points. So for instance, I'm going to make a t-chart. I'm going to make my x. I'm going to make my y right there. And I'm going to plug things in. I'm going to start with 0. 0's easy. If x is 0, what's 0 minus 1? Oh, my y is negative 1. Yeah, all right, cool. So I got 0, negative 1. Let's plot that right down here. Okay, I'm cool. Yeah. Next thing I've got, let's try if x equals 1. So I got 1 squared minus 1. Well, 1 squared minus 1. 1 squared's 1 minus 1, and that's 0. So if x is 1, y is 0. I plot it right there. Let's try the same thing with its counterpart, negative 1. If I put negative 1, quantity squared minus 1, and it all goes in the parentheses because x is negative 1, so everything goes in. Negative 1 quantity squared. Well, that's 1. Minus 1, we already know what that is. That's 0. Boom! Plotting it right there. And then the last is let's do 2's and let's do negative 2's. Now you notice 1, it got me the same as negative 1. So guess what? 2 is going to give me the same. It's symmetrical, man. That's why it's a quadratic. So I got 2. Plugging it in. 2 quantity squared minus 1. 4 minus 1. 3. So guess what? Oh, over 2, up 1, 2, 3. Boom. And I can say the same thing for the other side. Now, just connect the dots. Put your little arrows, kind of reminds yourself. And I've cleansed the demon. So, moving along. This isn't in your notes packet, but I want you to know how to do it. It's called finding x and y intercepts. Finding x and y intercepts, not difficult. You can do it. Ain't no tang but a chicken wing. So how to do it is you got to understand that for an x-intercept, if I plot on a Cartesian coordinate plane, so I'm just making this up right now. I've got my x, and I'm going to put a line. Wah! There's my line. This is my x-intercept right here. Right there. It's my x-intercept. What you got to notice is my y value of my x-intercept is at 0. And in fact, my y value of every x-intercept is going to be 0. So what you need to understand is x can be a number, but your y right here for your x-intercept, It's always going to be a 0. And just like it, I've got my y-intercept right here. And if I plot it, or shall I say write out the Cartesian coordinates, my x value is 0. This helps me find the x and the y-intercepts, because I need to remember that for my x-intercept, I've got an x value and a y value of 0. For my y-intercept, I've got a 0 for my x value, and I got my y value. So, that being the case, to find, I'm just going to erase this part. We don't need it. We don't need it. We don't need it. 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 To find the x and y intercepts of, let's say, this equation, y equals square root of 2x minus 1, to find the x-intercept, again, my y value is 0. So I'm going to say y is 0, and that's equal to square root 2x minus 1. And now just solve for x. Okay, not a problem. I can do it. I got to get rid of a square root first. How do I get rid of a square root? Square it. And then when I square everything, the square root and the square root and the square cancels out. So what I've got left is 0, because 0 squared 0, equals 2x minus 1. And now, just solve like normal. Plus 1, plus 1, 1 equals 2x divided by 2. And I have 1/2 equals x. So, last one I've got here is for the y-intercepts. To plug in the y-intercepts, I've got a 0 for my x value. Right here, 0 for my x value. So, I'm going to do 2 times 0 minus 1. Yeah, in just about 3 minutes, if you don't mind. I'm sorry about that. Thank you. So I've got 2 times 0 minus 1, which right here, 2 times 0 is 0 minus 1. Put it under a square root. 0 minus 1 is -1. And don't forget, it's y equals. Now, here's the thing. What do you mean y equals square root of -1? Everybody knows you can't have a negative under a square root. Well, if you guys remember your Algebra 2, you will remember that anytime you have a negative under a square root, it becomes imaginary. Imagination. So what does it mean that it's imaginary? Well, it means that there's no real y-intercept. It really doesn't exist. Tell you what, let's take a look at the graph of y equals square root of 2x minus 1. I graphed it in Desmos Graphing Calculator, which, by the way, awesome, awesome tool. Right here, we've got our x-intercept. Remember? I told you it was 1/2, 0. By the way, this is 1 right here. This isn't 1. This is 2. Okay? So it's 1/2, 0. That's the coordinates. And where does it touch the y-axis? Where does it touch this one? Oh, I'll tell you where it touches it. It doesn't. It doesn't touch it. That's why it's imaginary. It doesn't exist. No real y-intercept. I've cleansed the daemon. Well, thank you very much. I appreciate your time. Have a great day. Enjoy your weekend, you guys. By the way, do your homework. All right. Peace.